Let's use differentials to approximate the cosine of 59 degrees. When we say differentials, we're basically using the tangent line to make an approximation. And so it's a first order approximation. And what I've written down here at the bottom of the board in blue, as long as the change in x in absolute value is relatively small, the first order approximation is reasonable. So we don't want delta x in absolute value to be much bigger than 1. Otherwise, the approximation destabilizes. So what we have here for cosine of 59 degrees, first we're going to define our function to be cosine of x, and our distinguished value of x is 60 degrees because we know what cosine is exactly for that degree measure. And so now what we're seeing is that our delta x will actually be -1. That is, we've got 59 degrees minus 60 degrees equal to -1. Now, what is the tangent line approximation or approximation by differentials? That means the change in f, which is f of x plus delta x minus f of x, is approximately f prime of x times delta x. That's basically the equation of the tangent line. And so to make this a little bit more useful to us, let's just transpose the f of x to the right-hand side. And so we see that f of x plus delta x, which is what we're trying to approximate, is approximately f of x plus f prime of x times delta x. And so what we want to do now is simply substitute for our particular function. So our value here is 59 degrees, so we have f of 59 degrees, which is x plus delta x, is approximately f of x, f of 60 degrees, plus f prime of 60 degrees times delta x. Now let me give you a little bit of explanation about this. We notice here that f prime is just the additive inverse of sine x, so when we actually make our substitutions, we see that here. But why do we have this? Well, notice the delta x is -1 degrees, but degree is not the pure measure that we need to do calculus. So we want to use the approximation, actually not the approximation, but the conversion between degrees and radians. So if we want to convert from degrees into radians, we use this conversion formula, which you learned in your pre-calculus class. So for -1 degrees, we want to substitute -pi over 180. And so now we can move to the actual definition of f and f prime. So we get cosine of 60 degrees minus sine of 60 degrees times the -pi over 180. Of course, the negatives absorb, and we have 1/2, which is the cosine of 60 degrees, and sine of 60 degrees is √3/2 times the pi over 180. So this gives us an exact approximation to the first order. Now, if we're interested in actually getting some decimals here, I use my Google calculator on this, and you'll get approximately 0.0151, and add to 0.5, you get 0.5151. Now again, this makes perfect sense. We know that on the interval from 0 to pi over 2, that the cosine function is decreasing. So we would certainly expect that the cosine of 59 degrees would be greater than 1/2. And so in this case, we have a decent approximation of 0.5151, and we are done.